In this lecture, we study the Werner's theory of coordination compound. In coordination chemistry, the Werner's theory has too much importance as it was the first theory explaining the nature of complex compounds. This theory is based largely on the work of Alfred Werner. Alfred Werner carried out number of experiments during 1880s to 1890s. In his experiments, he had studied properties of several metal halide complexes with ammonia. For example, five different adducts of ammonia with cobalt chloride were known at that time, which has the general formula COCl3NCH3. Some of the Werner's original data obtained during this experiment were shown in this table. Werner used the molar conductance of solution of these complexes to find out number of ions per unit formula and the precipitation of chloride ions by silver nitrate to find out the number of chloride ions. The first complex was orange yellow in color. The molar conductance of its solution indicates there are 4 ions. Out of these, 3 chlorides were precipitated by silver nitrate, indicating that there are 3 chloride ions and 1 coordination pair. The second complex was violet in color. The molar conductance of its solution gives 3 ions, whereas treatment with silver nitrate, 2 chlorides were precipitated, indicating that out of these 3 ions, 2 are the chloride ions and 1 is the coordination pair. The third complex was green or violet in color. Its molar conductance indicates 2 ions, whereas treatment with silver nitrate gives presence of 1 chloride ion. It indicates out of these 2 ions, one is a chloride ion and another is a coordination pair. Fourth complex was blue-green color. Its solution does not conduct current, indicating that there are no any ions. Further, on treatment with silver nitrate, no one chloride is precipitated, which indicates that there is only coordination pair, there are no ionizable ions. The fifth complex was pink in color, which indicates its molar conductance indicates 4 ions and 3 chlorides were precipitated by silver nitrate. Based on these data, Werner has made some assumptions, made some conclusions. The basis of these, the basic conclusions are, he thinks that the metal ions must have two type of valencies. He has given name as first primary valency. This primary valency is the oxidation state of metal ion and corresponds to the positive charge present on the metal ion. And the second type of valency is the secondary valency. This secondary valency is equal to the coordination number of complex and that is equal to the total number of ligands bound to the metal ion. Alfred Werner wrote this theory at the age of 26 and this theory has become a guiding principle in inorganic chemistry. He is regarded as the father of coordination chemistry and awarded Nobel Prize for this work in 1913. We will see some assumptions made by the Werner. First was the central metal ion must possess two type of valencies. One called as primary valency. This primary valency is ionizable. Second valency is the secondary valency. This secondary valency is non-ionizable. Primary valency is those which metal has in its simple salt, that is, it is the oxidation state of metal ion. The secondary valency represents number of ligands attached to central metal ion. The secondary valency is also termed as the coordination number of this metal ion. This secondary valency is non-ionizable. The primary valencies are non-directional and can be satisfied by only negative ions, whereas the secondary valencies are directional and may be satisfied by negative ions or neutral species or sometime may be by positive ions. Again, he has said that a negative species may satisfy primary as well as secondary valencies simultaneously. The secondary valencies are directional in space, and hence such compounds are capable to exhibit the phenomenon of isomerism. This was found the basis of stereochemistry of metal complexes. Thus, in 6 coordinate complex, 6 ligands must arranged octahedrally around the metal ion, and in 4 coordinated complexes, ligands may arranged either tetrahedral or square planar depending on the hybridization. These assumptions were these assumptions were tested experimentally on the experimental evidences, and these evidences supports these points made by the Werner. Werner used molar conductance, as we have said already, to find out number of ions per molecule. He has used precipitation of chlorides by silver nitrate, as we have said already, and he has used treatment of these complexes, solid complexes, with H2SO4 to find out the number of chloride ions. The first complex, which was orange yellow in color, having formula COCl3 6NH3, he has given name as luteo-cobaltic chloride. This complex, when treated with sulfuric acid, all chloride ions gets removed, which indicates that all COCl bonds are ionic. This complex, when treated with silver nitrate, all chlorides gets precipitated immediately. When this complex is treated with hydrochloric acid, even at 100 degrees Celsius, ammonia is not removed, which indicates that ammonia is strongly bonded to the cobalt. We may say that the ammonia is in coordination pair. The molar conductance of its solution indicates presence of 4 ions. One is the complex ion and another 3 are the chloride ions. Based on these evidences, we may say that the 6 secondary valencies are satisfied by 6 amine ligands, which is shown by solid lines in this diagram, and the 3 primary valencies are satisfied by chloride ions, which are shown by dotted lines. And the formula of complex may be written as CONH3 6 times in coordination pair and Cl3 ions are outside the coordination pair. Second complex was violet in color, having general formula COCl3 5NH3. He has given its name as perchlorocobaltic chloride. This complex, on treatment with sulfuric acid, only 2 chlorides gets removed, which indicates that 2 COCl bonds are ionic. Again, on treatment with silver nitrate, only 2 chlorides gets precipitated immediately, which indicates that there are presence of 2 chloride ions in its solution. The molar conductance measurements indicates presence of 3 ions. One is the complex ion as shown and 2 chloride ions. On these evidences, we say that 5 secondary valencies are satisfied by amine ligands or amine molecules, which are shown by solid lines. 2 primary valencies are satisfied by chloride ions, which are shown in dotted lines in this diagram. Again, we say one chloride ion is satisfying both primary and secondary valencies at the same time. That is, one chloride ion is inside the coordination pair. The formula for this complex may be written as COCl NH3 5 times in coordination pair and 2 chloride ions outside the coordination pair. The third complex, having general formula COCl3 4 NH3, which has named as praseocobaltic chloride and green in color. Its molar conductance indicates presence of 2 ions. One is a coordination pair and one is a chloride ion. On treatment with silver nitrate, only one chloride gets precipitated, which indicates that there is only one ionizable chloride ion. On this basis, we say that 4 secondary valencies are satisfied by amine molecules, 1 primary valency is satisfied by chloride ions, and 2 chloride ions satisfying both primary as well as secondary valencies simultaneously. That's shown by dotted lines. The formula of complex may be written as COCl2 NH3 4 times in square bracket and one chloride ion outside the square bracket. The next complex was violet in color, has general formula, have molecular formula same as previous COCl3 4NH3, which is named as Voilio cobaltic chloride. The difference is that previous was green in color and whereas this is violet in color. Its molar conductance and treatment with AgNO3 also indicate same evidences as previous one. So but the color is different, so we may explain this as they may be isomers of each other, and Werner said that the previous was trans isomer and this is the cis isomer of the complex, that it indicates the presence of isomerism in these coordination compounds. The last complex was blue-green in color, has formula COCl3 3NH3. It does not precipitate any chloride ions on treatment with silver nitrate. Its dilute solution does not conduct electricity, indicating that there are no any ions. From the above fact, Werner concluded that the three amines were satisfying three primary secondary valencies and three chlorides were satisfying primary as well as secondary valencies simultaneously. On these experimental evidences, we prove that the assumptions made by the Werners are explainable, and by with the help of Werner's theory we successfully explain the formation of these five different adducts of ammonia with cobalt chlorides. Thank you.